Bottom of the morning to you. We're drinking from the Saturn cup today, friends, because I want to talk about time. I mean, even as I'm considering finding a schedule to more regularly broadcast live streams like this, there's a question of should I arrange this schedule to natural time or civil time? Speaking of time, it is currently 11:26 p.m. Pacific Standard Time on January 12th, 2023. According to whom, right? Like, who defines that, and how do I just like push a magic button and the magic box tells me this number? And it's very convenient because I know, for example, that I need to be in a session with a student in 18 minutes. But what's a minute, right? And these minutes these days, what's a day, are computed according to civil time. So you'll see that the subject of our short discussion today is pots and poles. Why? Pots, civil time. Poles, natural time. What do I mean by this? Get outside and put a stick in the ground. That's the pole, okay? And you will watch on sunny days and never at night the shadow move from pointing west at sunrise in the east to pointing east at sunset in the west. Now the sun only rises due east and sets due west 2 days a year that we call equinox. So typically that shadow is either going to move from the northwest to the northeast or from the southwest to the southeast. But basically you get, especially in the northern hemisphere point of view, this clockwise motion of the shadow of the pole moving from the west to the north to the south each day as the sun moves from the east to the south to the west, right? The sun in the northern hemisphere sky moves clockwise. We used to call this sunwise. And of course, this is one of the very natural expressions of time. I mean, people say time is an illusion. It's like, okay, I notice you are wrinkling a bit, my friend. Like, do not deny Saturn, right? I said that and a bunch of tarot cards just fell on the ground. I want to honor the language of the birds and share the symbols as they come through, friends. Right? I mean, does your Earth not spin? Our Earth's rotation in respect to the day brings that, or to the sun is the solar day, right? Sunrise to sunrise or sunset to sunset. Midday to midday, perhaps the easiest of those to measure. Why? Because the shadow of the pole is shortest at midday when the sun is on high. We used to call that noon, friends. Now we call it local apparent solar noon, right? Because noon has become this 12 o'clock thing, this expression of civil time. Anyway, so as we speak about time on the pole, there's not only putting a pole in the ground or standing straight and being one and doing the shadow work, right? This is natural time, exploring the time of the day. The pole will also speak the time of the year because the midday sun is always on high, casting the shortest shadow. But of course, the summer solstice midday sun is the highest sun. I should say that if you live between the tropics of Cancer and Capricorn on Earth, that's not necessarily true because the sun will actually go directly overhead twice a day. But let's talk about temperate northern hemisphere experience. The summer solstice sun is going to cast the shortest midday shadow of the year, and the winter solstice sun the longest midday shadow of the year. So you can work with that same pole that tells you daytime by the spinning of the shadow. And that's, the reason why our clock faces have that clockwise motion of a line. Yes. And you can also work with the length of the midday shadow to tell where you are in the course of the year. And this is all natural time. In fact, again, like that sunrise due east only happens twice a year at equinox time. And do you have a perfect view of the horizon anyway? There's other interesting astronomical considerations. But generally speaking, if you watch your sundial at sunrise throughout the course of the year, you're only going to get due west shadows at due east sunrise, like twice a year at the equinoxes. So natural time, very importantly, it's not as civil time. So what do I mean when I say civil time? I mean like equal divisions, right? A second is an equal period, a minute an equal period, an hour an equal period. There's an interesting place for us to even speak about what I'll call pole time versus pot time, or natural time versus civil time. Let's talk about the difference between astrological hours or planetary hours and civil hours. The civil hours are the ones that we know, 60 minutes of 60 seconds each. Tick tock, tick tock, tick tock. This is civil time. It's very regimented and the like, right? When did that begin? Oh, with the first mechanical clock? Perhaps. Let's get back to that. But to look at natural time, like in planetary magical time, astrological time, what is done, rather than having some tick tock of a clock and every hour being of equal length, the daylight hours and the nighttime hours will be of different length, except on those 2 times a year when daylight and nighttime are equal. Let's speak in civil time, right? If you have a 24-hour solar day, around equinox time, you'll have 12 hours of sunlight and 12 hours of nighttime, right? Here we are in the northern hemisphere in the winter time when the days are much shorter than nights, right? And what we do in planetary hours is we take the length of daylight and we divide that into 12 equal sections, and the length of nighttime and divide that into 12 equal sections. Let's say in this 24-hour day, we happen to live on a place on Earth where at this time, the daylight hours are like 10 civil hours of the 24, and the nighttime hours would be the other 14. Okay. So the planetary hours, we would take those 10 hours of daylight, 10 civil hours of daylight, 600 civil minutes of daylight, and divide that by 12, so that each of the hours would be, the planetary hours would actually be 50 civil minutes long, right? The daylight hours are shorter, and there's 12 equal 50 civil minute hours to make the 10 civil hours of daylight, and that the nighttime hours would then be 70 minutes each, or 70 civil minutes each. So it's, it's strange to say that like on a 10-hour civil time day, right? Daylight being 10 hours of civil time or 600 minutes of civil time, you're going to have 50-minute hours of planetary hours. And it's weird because I'm actually speaking natural time and civil time in the same sentences, but this is actually going to be necessary. We want to start like taming our natural experience of the sky so that we can make the train on time. All right, so let's speak about how some of this worked in the ancient days. So poles, like literally sticking a pole in the ground or standing tall and doing the shadow work, which can't happen when the clouds are out, as it has been recently in California. I'm actually seeing shadows on the fence out here for the first time in many days. And of course, you cannot do work with the shadow of a sundial on most nights. Now, when the moon is bright, you actually can, but let's not be there right now. Or maybe I should, because let's speak about other increments of natural time. Like, how would we have done this back in the carving the phases of the moon on animal bones days? Like that, okay? So the kind of natural periods of time that we experience as Earthlings is one, the rotation of our planet. This is called the primary motion, or the primary period, in respect to a distant star or cluster like the Pleiades. That rotation, sidereal day, it's called, is like 23 hours and 56 minutes. But in respect to our star, to the sun of our sky, so sunrise to sunrise or sunset to sunset, interestingly, in our day and age, like we're measuring from midnight and not quite. But anyway, midday to midday is kind of an easy one to do because, again, it's like the shortest shadow of the pole. And in the northern hemisphere, since the midday sun souths, the shadow norths, and it's very easy to see. I mean, you're much more likely at that time of day to have clear skies. The sun is on high. You're going to have less obstruction from trees and other things on the horizon. And if you get the shortest shadow one day and just draw a line in that direction, it's a meridian, it's a north-south line, and then every day you see the shadow hit that line, you know it is true solar noon, the height of the light halfway between sunrise and sunset. And it's very easy, therefore, to measure that day, or to see the expression of a day, one earthly rotation with respect to the sun, and like the shadow hits the meridian line to the shadow hitting the meridian line the next day, right? It's going to do that about 365 times during the course of the year. But before we get to years, let's talk about months. Many ways to do months. When we follow the sun through the signs, as many of us are today, we're really looking at sunths, how long it takes the sun to move through a 12th part of its journey around the earth, at least from our point of view. That's a 12th part of space, not of time, because since earth is closest to the sun in January and furthest away in July, the earth travels at different speeds, or from the earthly experience, the sun travels at different speeds throughout the course of the year. So the sun makes it through the signs of Sagittarius and Capricorn much more quickly than it does through the signs of Gemini and Cancer. If you take the year, the solar year, Earth's orbit of the sun, or from our point of view, the sun's journey about us through the constellations and through the signs of the zodiac, then this is a period of about 365.2422 days, right? And many of us learned it as 365 and about a quarter of a day. Well, if you divide that period of a solar year by 12, then you see you have an average of about 30.4 days for the sun to make its way through one of the equal divisions of the ecliptic, a sign. Whether you're using tropical signs as I do, or sidereal signs, as long as they're 12 equal parts, the average time for the sun through a sign is 30.4 days. Hence calendars that switch between 30 days and 31. But many calendars which do months with the phases of the moon, which is actually our earthly experience of the moon reflecting sunlight to our eyes, right? So it's earth, moon, and sun, will switch their months between days of 29 and 30. Because why? Well, the lunation, the average lunation, new moon to new moon, is about 29 and a half days. 29.53059, but who's counting? We are, and that's really necessary. If you want to create natural calendars that actually synchronize the golden and silver time, Earth sun time and Earth moon sun time, that's a tricky thing to do, and that's a long conversation. I'm excited to teach a long workshop around this later this year. So be on my mailing list if you want to hear about that. You can sign up at GeminiBrett.com. Brett has Gemini T's, twin T's, of course. Okay, so switching between 29 days and 30 days in a month averages a 29 and a half day pace, very close to the time of an average lunation. I mean, this would be this, I guess, intermediate period of natural time on the earthly witness. We experience the Earth's rotation by witnessing the rotating sky, including sunrise to sunrise, or midday, short shadow to short shadow, or sunset to sunset, right? So the day, dividing that into 24 hours, whether we do that in civil hours or planetary hours, like, where does that come from? That seems to be more of a human invention than the other things. Like, tracking the days is not an invention. That's a discovery or choice to align to nature, frankly, and it's something you better do. These days, of course, a little bit less necessary with our bright urban lights and all the things, right? But let's set that aside for now. So the days, right? Earth's rotation, the weeks being half of a fortnight about, but new moon to full moon is more like 14 and 3/4 days, and it is 14. Like weeks are kind of tricky, and I think that's a topic for a deep dive another time as well. But we can speak certainly about moonth time, new moon to new moon, or the first visible moon in the sunset west, the waxing crescent, the sliver crescent, Diana's bow. I mean, that was often utilized as a visual indication for the new month or the new month. 12 of these periods, if you're using a calendar that switches between 29 and 39 days to keep the 29.5 day pace of an average lunation, 12 of those periods is 354 days. And the issue, of course, is that's not a year. So you need intercalary months if you want to synchronize a silver year of 12 months in the golden year. I mean, amazingly, what happens is over 19 solar years or Earth orbits of the sun, you get 12 years with 12 months, alternating between 29 and 30 to keep the 29.5 day average pace of a lunation, 12 years of 12 months, and 7 years of 13 months. And these 19 years, we call this the metonic cycle today, right? And this is all in natural time. I mean, we need to tame this to write it up on a page and like issue a calendar that will help us get to the train on the right day, right? Of the right month and in the right hour. But what is an hour? Again, hours might be a little bit more arbitrary, and pots and poles, the pole being natural time, those natural hours, it makes more sense to divide daylight into 12. These are called planetary hours, or nighttime into 12. Speaking of nighttime, we can't work with that pole in regards to its shadow during the night, although full moons certainly do cast a long shadow from your sundial too. But we can work with that pole in a very important way. Speaking of time, I gotta go. So let me make this quick. That pole, if we draw the line of the shortest shadow during the day, we drew a meridian, we drew a north-south or south-north line. We can stand on that line and look at the pole at night, and we will watch the stars culminate, reaching their highest height and then come down, just as the sun does at midday. This happens with, the wanderers like Jupiter and Saturn, but also with the fixed stars like Hamal, okay? And this is an ancient way of keeping time, star time, right? Whether we're watching stars rise, it's a little bit trickier there because the different signs of the zodiac, because some rise crooked and some rise straight, to use the ancient terms, actually take different amounts of times to rise. It's like an important truth. Whereas the meridian, it's about 4 minutes, or really 3 minutes, 56 seconds for each degree to culminate. And to be more accurate, that's not in longitude like zodiac degree, but in right ascension, and I digress, okay? But the Egyptians, for example, really invented, the foundation for horoscopic astrology, where the horoscope is the ascendant, because they were looking at these rising stars to tell time during the night, or later looking at culminating stars to tell times during the night, which is actually a little bit more accurate, and you can use your pole to do this, okay? And it brings actually your witness closer to like a natural time experience, the stars, closer to a civil time experience of like regular increments of time. So let's speak about that. Why do I call this pots and poles? Well, the pole is really tracking natural time, whether it's like the shadow cast by the sun during the day, the stars culminating at night. Pots is a reference to water clocks. Check it out, all right? There were candle clocks, right? So an average length and diameter candle is going to take about the same amount of time to completely melt as its neighbor will. Now, there's a lot of conditions that are going to make that not exactly precise. Incense clocks were used for a long time, and some places still are. They're pretty genius. But the water clock is this amazing device. And if you look at the evolution of the water clock over time, you will find that it's basically led to the mechanical clock, where we keep like precision time, right? And now we're at quartz and then atomic clocks and whatnot. But look into the water clock, because if we want to look at the history of astrology, for example, there was the natural time working with the pole, working with the shadow by day and the stars by night. And there was then civil time, regular time, because if you can figure out how to keep the pot full, okay, of water, so you can get a consistent rate of the water drips, well, that water then will fill something or do other amazing things. Check out water clocks. I'll be speaking a lot about them in this time class. And understand that basically these were the ways of time in the ancient days. And we have the pole being very much an expression of natural time, especially by day. And then the pots, the water clocks, being an expression of civil time, regular time, and the way that those two relate, right? Like, oh, nature and taming and measuring nature, if you will, although certainly dripping water is natural too, like brings to us this amazing marriage, really, of the measurable, the immeasurable, the quantity, the quality, the astronomy, the correspondences, the heaven and the earth. And we lose this these days when we just grab a box to say it's 11:47 and I'm too